So the next question we have says calculate the inductance L of the coil in the circuit diagram shown above. Okay, we have a circuit diagram. This is the circuit diagram. Okay, so the question wants us to calculate the value of L in this given circuit diagram. And you guessed right. The formula for calculating um, capacitive inductance is XL is equals to 2 pi FL. Okay, that's the first thing. Now, in this particular case, this is an inductor only circuit. It's an inductor only circuit. So we only have an inductor there. And you recall that I told you something very, very important. I just feel like mentioning it again. That whenever you have an inductor only circuit, let me zoom in so that you can see that point again. Whenever you have an inductor only circuit, the current lags the voltage by 90 degrees. It means the phase difference is 90 degrees. That is, the current lags the voltage in an inductor only circuit. In a capacitor only circuit, the opposite is the case. Okay, in that case, the current leads by the voltage. In a resistor only circuit, the current neither the current nor the voltage lags. The phase angle is zero. Okay, the phase angle is zero. But in inductor only circuit, the current is lagging, while in a capacitor only circuit, the current is leading. So I just feel like mentioning that point again. Since we are still a question on inductor only circuit. Now, if we have an inductor only circuit, it means the voltage across the inductor VL is nothing but what? IXL, just like your Ohm's law. The voltage across that component is going to be current times the reactance, the inductive reactance, just like V equals to IR, but in this case to be V equals to IXL, because XL is the inductive reactance. Now, first we have to calculate the voltage, but we have to calculate our XL. The voltage is not specified. Okay, the voltage, I don't think the voltage is not specified. Let's check the question. Let's so that we will not make unnecessary assumption. Yes, calculate the inductor. So no other information is given. This is all the information we have. We have the frequency, we have the current. That's all we have. We have the frequency and we have the current. So let's see how we can use these two information to figure out all we need. So it will be difficult for us to calculate XL because we don't know L. We don't the value of L is not known. Okay, I can see what's happening here. What we have here now is not well written in the diagram. This is 220 volts. This is 220 volts, comma. This is supposed to be written as 220 volts, comma, and 100 over pi hertz. This is the correct way to write it. 220 volts. That's the voltage that we are looking for. That will be the voltage across this component. So from there, we can calculate our XL. So XL is going to be VL divided by I. So our V is nothing but 240 and our I is 2. So from here, XL can be calculated as 120 ohms. So since we know that it is 120 ohms, so and from our XL is equal to 2 pi FL, L is going to be XL divided by 2 pi F. Okay, and XL has been calculated as 120 and 2 pi. F has been given as 100 over pi. 100 over pi. So pi goes here. So we have 120 divided by 200. Okay. So without wasting time, you can just punch your calculator as do 120 divided by your 200. So you get 0.6. So L is going to be gotten as 0.6, and don't forget your unit. It's going to be measured in Henry. So I think that's a very straightforward question. Okay, the question just wanted to apply, just wanted to know that this is the formula for voltage, the voltage, current, and um, reactance relationship. V is equals to IXL. So using that to compute your XL, and using that XL to compute your L, substituting all the given variables. In the next question, without wasting time, let's see if we can solve two more. In an electric circuit, an inductor of inductance 0.5 Henry and resistance 550 ohms is connected. Now in this case we have an inductor, and we have an inductor, and we have a resistor. Okay, and it's connected to an alternating source with 500 with 60 heads. So we want to calculate the impedance of the circuit. So you remember the formula for your impedance. Z is equals to what? The square root of r squared plus xl minus xc all squared. But obviously in this circuit we don't have a capacitor, so we'll take the capacitor to be 0. So if you substitute 0 there, your formula boils down to square root of r squared plus xl squared. Okay, so you quickly need to calculate your xl, which is 2 pi fl. Okay, and L has been given to be 0.5. Okay, frequency has been given to be 60. So you have 2 multiplied by pi, multiplied by 60, and multiplied by 0.5. Okay, so without wasting time, just punch 2 multiplied by pi. Pi you can use 3.142, or you can use 22 over 7. Multiply, okay, the question did not specify, so let's use it as 22 over 7. So 2 times pi multiplied by 60, then multiply by 0.5. Okay, we'll get around 188.495. Okay, which is approximately, okay, let's use it this way, don't let us approximate yet. So for us to now get our Z, so we say Z is going to be the square root of our um r is 50, so 50 squared plus 188.495 squared. So we square this value, squared, then we add 50 squared, then we take the square root of that answer. So we got 195.014. So Z is computed to be 195.014. So which is approximately 195 ohms as our impedance. And you will see that the correct answer here is option option C, I guess. This is option C. So that's as easy as that. As easy as that. Okay, so um let's quickly go through. I believe this is very, very clear. It's very, very straightforward. It's a very, very straightforward question. In fact, if you are familiar with it, you might not need to write too much. Just punching calculator 2 pi times 6 times 0.5. You get that. You square it. After squaring it, you add the square of 50 to it, then you take the square root of the answer. You get your answer straight up, no stress. So the last question we have is the inductive reactance. So the inductive reactance in a circuit of frequency 100 Hz is 1 ohm. So we are given the inductive reactance in this case. Okay, to calculate the inductance of the inductor. So that is XL is equals to 2 pi FL. XL is specified, is given directly. That's the inductive reactance. It's given to be 1. Okay, then you have 2 pi F times L. The frequency is not specified. Okay, sorry, the frequency is given as 100 Hz. Sorry, the frequency is given as 100 Hz, and we need our L. So we just say L is 1 over 2 pi F. Okay, we just need to divide both sides by 2 pi F so that we can get our L. So we have 1 divided by 2 pi multiplied by 100. And we were instructed to use pi to be 3.14. So all we need now is to substitute. So 1 divided by 2 times the entirety of 2 times 3.14, everything multiplied, also multiplied by 100. So we get 0.001, 0.001592 Henry. Okay, and this is in standard form. This is 1, 2, 3. This is 1.592 times 10 raised to the power minus 3 Henry. So the closest answer here is uh, is option option B. The closest answer here is option B. So since the question did not ask you to approximate, so you have to, since you have 1.592 in the option, you have to go for 1.592. Okay, I believe that is very, very clear.